Hello everyone, today we bring you the disassembly and assembly of A14 CPU. This is a normal ID board. We will use it for disassembly and assembly, and then show you the layering and laminating of A14 CPU board, as well as the teaching of CPU disassembly and assembly techniques. We first layer it. We use a heating table for layering. Let's buckle the heating station first. Then we put on a small screw like this. People who have studied our course generally know this. This will help us to remove it easily when layering. Then we turn on the heating station. Because in the past, iPhone X, XS, XS Max, and to iPhone 11 models, it used to be kind of low temperature of 138 centigrade. So in the iPhone 12 series, its temperature is much higher than before. It is close to 183 centigrade team pace temperature we use. So according to the previous layering method, the temperature of our heating table is adjusted to about 180 centigrade. So our current iPhone 12 series needs to be adjusted to about 220 centigrade in order to layer this motherboard. Let's wait for it to heat up. The temperature we use is 220 centigrade. At this time, we can see that there is already flux on the side. When we are heating the heating table, the temperature is not fixed. In other words, how much temperature we adjust is random. We have to observe the changes of the motherboard. For example, the motherboard starts to smoke. For example, there was a bit of flux just now. We will start to look at it and try it. You can take it. If you can't take it, it's definitely not completely melted yet. We also need to observe the changes of the motherboard at any time. According to the change of motherboard, the temperature is not fixed. Because we are in different environment, some people may perform this operation under the air conditioner. Some people may be in the higher temperature environment. So we have to look at the response of motherboard to proceed to the next step. For example, if the motherboard emits flux or smoke, we can try to move it. See if the screw can be lifted up. It still can. Let's not use too much force, just try it lightly. Because if it reaches the melting point, it can be layered by gently holding the entire motherboard. So we should pay attention to this change of motherboard. Let's try again. Still can take it. Now the temperature has reached 195 degrees. By this temperature, the tin in the middle layer has not completely melted yet, so you'll need to wait for a while, like iPhone X to iPhone 11. Generally, the temperature of the heating table rises to about 160 degrees. We can take it down. Like this, our temperature rises to 200 degrees. We still can't get it. It shows that the middle melting point of iPhone 12 is much higher than that of previous model. It started to smoke. Let's try again. Can't hold it. We can insert it next to see if it melts elsewhere. Have not melted yet. Keep waiting. That's it. Everyone noticed that when we took it, it was 215 centigrade to 216 centigrade. After you take it down, you must quickly turn off the heating table, because there is still residual temperature on the heating table. Because our lower motherboard is still on the motherboard, then quickly remove the buckle and quickly remove the lower board. Then quickly remove the heating table. Because of this, there is still residual temperature on the heating table. So if you don't take it away, it may cause the heating table to use residual temperature to explode the tins of cheese in the lower layer. This will cause a short circuit or the failure when you install the motherboard. So pay attention to this detail. Let's observe. At this time, we can take a look at the motherboard of our iPhone 12 and observe. The CPU is in the middle. This is our A14 CPU, and there is the shell on the back. This shell inside the PMU, in fact, is quite dangerous to handle the CPU of the iPhone 12. Pay attention to the temperature control. It may easily blow up the PMU. Take a look at the microscope. First, we have to remove the screw. Let's take a look under the microscope. This is one of our A14 CPU. Actually, we can see something like A14 CPU. Only this row on both sides has a small resistors. Then there are small resistors in the row, but these resistors are basically useful. Also be careful when removing the glue, and then it looks like there is no small resistors on the two sides, so we can clearly know where to insert the blade. Let's take a look at the rough structure. Take a look at the motherboard structure of the iPhone 12 Pro. Take a look at these chips. In fact, iPhone 12 is very easy to drop past when encounter heavy fall at this corner. You can take a look here when there is a problem. This is an upper layer of ours. The NAND is here, the PMU is here, and the CPU is here. Then we look at the lower layer. Because you can see that this power amplifier are a lot more. Because of 5G is added to the iPhone 12, a lot of chips are added to the power amplifier. Then this is a 5G baseband. Let's first disassemble and assemble the CPU directly. Then we put on the PCB holder. Next, we start disassembly. First, let's take a look at one of our tools for removing glue. There are actually many options for removing glue. Let's take a look at several types of scimitar, several types of rubber removal blades, like this hook type. Then this jump life type can also be glued. There is also the kind of small hook type that can be used to clean glue. In fact, this model can be used to remove glue, and then take a look at our CPU. And like this kind of plane is to pry the CPU. And like this, you can pry the CPU. This kind of art is also used to pry the CPU. Before we get this plane, we use this fine sandpaper to grind. It's already used like mine, you don't need to grind. But if you just buy a new blade, no matter what the blade is, it's best to use this kind of fine sandpaper to sharpen it. These are on the edges. It will be easier to use after grinding. Then you can sharpen it like this kind of glue removal knife. This kind can be green in this way. Just use this kind of fine sandpaper. Next, we enter the main theme to start. Disassemble and assemble the CPU. Then we use the quick A61DW hot air gun. The temperature is 320 and air is 30. To clean the edge glue. Then we can start from the periphery of this resistor to insert the blade. Hook a glue open here. Then remove this glue. Be careful when removing this glue, because there are too many small resistors next to it. You drop the small resistor, that's the reason for your failure. Because these small resistors are useful, you must not get rid of small resistor. Then there is another side. The resistor on this side are upright. Putting it upright is easier to get rid of, so be careful. First, make a small opening. Use this kind of blade. Why do we need to sharpen the blade at the beginning? First, it will become sharper, and second, it will become thinner, because the gap between the glue and small component is too small. So we need to polish it. Remove the two sides. There is also a small amount of glue on the two sides. In fact, the glue on iPhone 12 is relatively small compared to other models. Remember to remove the glue on both sides. Can be lazy, like A14 CPU. Its edge glue is very easy to remove. Just remove the glue on the both sides of resistors. There are some resistors on the side, and then there are some resistors on the opposite side. Gently remove the two sides, we can pry directly. So it is much easier than other models. Then take out one of our jumping knives that we had just polished. Then take out our hot air gun. We are now using a mid-mouth wind nozzle to clean the glue. Then when prying the CPU, We use a nozzle that is one size larger. It's the 8mm nozzle. Then we now go to adjust the temperature of a prying CPU. Then we pry the CPU to use the A61DW air gun with a temperature of 420 centigrade and a wind speed of 40. To pry a CPU at this temperature, we are now going to pry a CPU. Adjust the position. Because here the blade is easy to start. Why did I adjust the position of PCB holder just now? Because like before, this kind of PCB holder has a cutting edge. There is no such gap inside like this. It is not convenient for us to cut. Like the position of the clamp on this motherboard, this detail should also be noticed. You can see that our temperature is 420 centigrade and the wind speed is 40. Then we are going to start prying the CPU. To pry the CPU, first we need this big nozzle to rotate directly. Rotate in this way and rotate evenly within the range of the CPU. Then this knife can be tried on this edge. See if it melts. If it doesn't melt, continue to wait. Try on the edge. You can insert a little bit, there's almost time. At this time, the CPU is about to be pried off, and the back of this one should also be noted. Because sometimes the front part has melted, but the back part doesn't melt. It is easy to cause one of our job pads, so heating should be even. You can insert a bit at this time, so let's look here first. Don't plug it in yet, plug it on the other side. At the end, insert in the middle. Remember that it was heated at the end just now. It was the place under the Apple logo that was heated. Otherwise, the tin point is not completely melted. It is easy to cause the point to drop. Let's take a look at this time. At this time, let's take a look at one of our prize CPU. It can be seen that the state of our current CPU is very perfect and no point is dropped. Then let's start the pass again and see how we pry them. Let's start this prying technique. We just heated the inner ring first. Rotating heating is such as a uniform heating. Take this knife and stroke it aside before you are going to pry at the end. You can test whether this melts. Then gently insert it a little bit. If you can insert it, it's fine. Then switch to the other side to plug in. Insert in the middle when you want to pry up. When the blade inserted in the middle, the rear part of our air gun needs to be heated against this side. Otherwise, it's easy to cause pad drop, but sure to insert from the middle. Some CPU will bulge or deform, actually because you didn't insert them in the middle. If you insert it in the middle, it will definitely not bulge. Sometimes if you lift it hard here, when it is lifted, it may be stretched unevenly. When the CPU heats up, it is relatively soft. Then when we pry it, it becomes deformed. This is an analysis of one of our techniques. So we will do a process on this pad first. Then we now take out the fixed solder paste. We add a small amount of fixed paste on the pad. Then after we finish prying solder paste, add the original tin directly here to exchange tin. Because of original tin, its melting point is relatively high. Pads are easy to fall down when we remove the glue, and it is not easy to handle. We also need to add a little flux to speed up the auxiliary tin change. Then our soldering iron is generally set to the 250 degree to 360 degree. Like a soldering iron, it is recommended to use a blade. For the cutter head, you can wait for meeting and you can directly remove the glue. Another point, why do some students make A12 CPU or other CPUs? It will cause the PMU on the back to explode. This is a big reason that when it cleaned this CPU pads, it took a long time for this air gun. So when we deal with the CPU pads, I use this soldering iron most of the time, because the soldering iron will not hit most of the motherboard. It will only remove the glue on the edge of the knife, so its danger to the motherboard will be minimized. Then we use this soldering iron to make a small opening. It must be gentle but not forceful. It may scratch the motherboard if you force it. Then gently remove most of the glue first. You can see that all the glue now remains on the soldering iron, and then we continue to shovel. Be careful of the resistor next to it when shoveling. Try not to burn the tip of the soldering iron on the resistor, otherwise the resistor is easy to fall off. After shoveling, it can be seen that most of the glue has been shoveled after the first time of shoveling. So we use this soldering wick to set the tin on it first. Then when sucking the tin, dip the soldering wick with rosin. Then first perform a deadening on it like this. We will have to deal with the detail later. Why do we want to add rosin here? Because of its high viscosity, it can be better adhered to the soldering wick and the absorption to this residual glue and residual tin. Here are the details. Everyone should pay attention to these details. You can see that the glue on our last side is not shoveled with the soldering iron. This is also very important. Why don't I shovel it? Because the soldering iron shovel over may loosen the small resistors. So leave this the last step and use a blade to dispose of it. The blade is matched with the hot air gun, so these small resistors are impossible to drop. Then we take it off roughly, because this is not machine processing. Then we switch back to our 6mm stroke nozzle at this time. Then use the same temperature as we just set for the side groove of the CPU. temperature 320, wind speed 30. Clean the glue. First of all, we also open a mouth. Then shovel all the way. Any blade can be used for this. I'm using a surgical blade. We are using the number 11 blade. Remember to use the back of the number 11 blade. If you use the front of the number 11 blade, it is easy to scratch the motherboard. Like I just used the tip of the knife to make a mouth, it's easy to scratch. You can see here, so I use the back of the knife to perform an operation. Then shovel it all the way. At this time, the glue like the one I left just now will also be taken away. So why I didn't shovel with the soldering iron just now? Because I have to do in this step too. A risk of resistors can be avoided very safely. This is also the details. Everyone must pay attention to these details. In fact, CPU details are very important. After it's been removed like this, take the soldering iron and tin it again. Because this part of the tin just now has glue on it, we did not perform a good tin change on it. So we use a soldering iron to cover the 183 solder paste on these solder joints. Then we go to deal with the other side. The other side has already been dealt with. You can see that the soldering iron has passed the tin just now. Next, we first use the tip of a knife to make a mouth. Open a mouth at this time. After opening the mouth, we switch back to the back of the knife and shovel it all the way. This has completed an operation of removing glue on this side. Then we use a soldering iron to change the tin on this side. After changing, at this time we can add a little more tin. The purpose of this one-time tinning is for the pad to be better connected to the CPU. In case there is something oxidized, it can be better treated. There will be no solder joints that cannot be soldered. Go over this side too. After it's over, we will use this soldering wick to dip the resin. This time, all the solder joints will be flattened. Because this step is completed, you have basically completed a cleaning step of the CPU pad. Some are not clean, you just use a soldering wick to sort the unused place. It can suck very cleanly. Go and suck it up first. Suck it up. We will deal with the middle at the end. Try to make each pass as flat as beautiful as possible. It's important to do CPU details, because it has a point that can prevent your phone from turning on. This side should also be cleaned up. Now our pads have basically been processed. This has an effect under the resin, so let's clean it next. For cleaning, we use this cotton for cleaning. Cotton is stained with our PCB water. It can be cleaned several times when cleaning, because the pads also need to be cleaned. At this time, we can take a look at our pads. Every point must be cleaned well, perfect. In this way, the solder CPU will not cause problem. Now we can see that our edge glue has been cleaned, and this pad is also okay. Then we open our drawing. Like we have already removed the CPU, or after installing the CPU. Let's find its focus now. Like this new drawing, there is no number for this kind of capacitor. And we just click on one, it doesn't show what the line is underneath it. So now we teach you how to judge, how to measure whether the CPU is installed properly. For example, if this is our CPU, then I first find this pass in the middle. These pads are generally power supply pins. We can just click one now. You can see that there can be a lot of red dots in the line. They are all power supply lines. This kind of power supply line only needs to be maintained here and more than 2 points on the line. For example, when you were boiling, this point was not planted to this point. It does not affect your normal work. If this red dot falls on the pad or CPU chip, we don't need to deal with it as long as this red line is above. So many red dots exist and more than 2. It can provide normal working conditions for the CPU. For example, for this road, let's click 1 at random now. If there is no on this side, then it may be on the opposite side. There is a switch A-B side here, you can see in this line. The ones with lines on both ends are inductors. The ones with grounding at one end and the lines at the other end are capacitors. We are going to measure in this place. Now we come back to what we just talked about. For example, if these are just one point, they are not power supply lines. They are basically next to the PMU. So in the iPhone 12 series, this method is applicable to all CPUs. When you don't have a line and no tag identification, this is how we judge a power supply line of the CPU. In fact, the power supply line is regular. This is one, switch AB side. Then you look at this side, switch the AB side and click around the edge. This is the power supply circuit of the CPU. There are all inductors next to the PMU. You can click the other side to see and come back to this one. It also leads to the CPU side, which is the line with more red dots. We basically measure the CPU in this area because it doesn't indicate the normal diode value. So we need to make a measurement and judgment by ourselves, because the test point and PMU are on the back of the CPU. And there is the shell on the PMU and the test point. So we try not to remove the shell to measure these test points. There is a certain risk because the shell is sealed around. If it is heated directly, it will easily cause the PMU to explode. So we directly go to the DC power supplies to measure whether the current is normal. Let's look at the current next. We can see this is digital meter. If it is connected to the power supply now, it has no leakage. Then we go to press the power button. The power button is here and there is no response. Because this is a 2-digit digital display, it is normal to display 0.00 like this. But some motherboard will display 0.01, 0.02. In fact, it is also normal. As long as you turn on the current, it's 0.00, 0.01, 0.02 is normal. Because of different digital meters, its accuracy and precision are different. If you can handle this CPU well, the boot current will be very large. Then it proves that the PMU on the back has been short-circuited and the tin explodes. Now the stop current is normal. 0.00, 0.01, 0.02 are all normal. So let's move on to the next step. Let's deal with the CPU chip. This is our A14 CPU just now. We now start processing our CPU. For processing the CPU, you can add this kind of 183 tin paste in this step. Then add some flux. Then go and mix the tin. Mix it with the original high temperature tin. In this case, its melting point will not be so high. Then after we mixed it, we cut the soldering wheel into small sections. Then use the glue removal temperature we have just now. Temperature 320, wind speed 30. Let's take off the tin underneath. Almost after taking off, Then we use a knife from the CPU to remove glue. We blow first and wait for the tin board to melt when we blow. Let's use the soft blade to scrape. You have to wait until it melts if you think the melting point temperature is enough. The hot air gun can be taken away. Don't blow at it all the time, because this will also cause the CPU to be too hot. We must also control the way we use hot air guns. Then pay attention to the above. This side is processed, and then we will deal with the other side. You can see the tin board has obvious changes. When we feel it has melted, we cut the glue again. Otherwise, you can easily get rid of these points. This is a detail. Everyone must pay attention. If it doesn't melt, if your knife is on it, it's easy to get rid of that spot. This is why we want soft blades. It's not so easy to get rid of the point with a soft blade. If you use a hot blade, it hasn't melted yet, you might have shaved all the points. We continue to the other side. Divide the four sides first. Handle the middle last. Now that the four sides are processed, we will remove the middle part. There is one last bit here. After processing, we just go back to small amount of tin. Some points may be under the glue. They did not perform a good tin change. Maybe some points have been oxidized, so we need another layer of tin. Make each tin become a melting point of 183 and it will not oxidize. This is convenient for our tin planting and CPU installation. Then we cut some soldering wick and then flatten it. After changing the tin, we use a soldering wick to perform and flatten. Try to take it off as much as possible, and then check whether there is any glue left on it by the way. After this step, we can plant tin in the next step. Check by the way to see if there is any residual glue. In this case, we don't need to take it off very flat, because even it's not so flat now, and after the reballing, it will be flat. Unlike the pad, it must be flat. In this case, every solder joint does not need to be flat. But try to keep it as high as possible to keep its solder joints not high and convex. I will clean the CPU pads first. If there is a little glue, we can remove it directly with our fingers. We directly use the number 11 blade to remove it, using the back of the number 11 blade. You must pay attention to these details, otherwise if the glue is not removed cleanly, when you reballing, it is difficult to form a tin board. There is basically no glue left. Let's clean it again. Let's take a look at this time. There is no residual glue now. In fact, you can see a little bit of blacklist like this one. You don't need to worry too much to remove it, because it is a very thin layer of glue on it. If you remove it too deliberately, the knife may scratch the bottom line on the top. Instead, get the opposite result. A little bit of glue like this can be ignored. It will not affect your reballing. Then we remove the PCB holder now. At this time, we had to clean it up. It must be clean behind, and the edge groove will be scratched after a while. Also, there is a small amount of edge groove on the side to be removed. Remember, the knife must be straight, otherwise the chip will be easily cut. I would rather tap less, but don't damage the tree inside because the tapping is basically completed by this time. It can be cleaned after cleaning it again. Clean it up. After cleaning, take out our tissues. Then we open tissue like this and fold it in half. After folding in half, we can enter reballing. If the CPU is planted with tin, use this kind of 183 tin. Then we go and take this tin. Make an appropriate amount, and then we had to take a paper towel to soak it out. Otherwise, if there is too much flux in it, it is also a reason why you can't reball properly. Must be so dry before planting. Then we start reballing now. You can use this kind of curved tweezers. Then align the holes first. Line A14 is very good alignment. Because it has a lot of glass, you can fix the position with it. Then use curved tweezers to place and fix the reball stanchion. Keep it flat and then press half of it with the tweezers. At first, you only need to process half of the tweezers, because you may have a little bulge here in the middle if you hold the whole chip. So we only press half of it now, touch the tin after processing half of it. After wiping this half, move the tweezers to the middle and divide it into 3 sections of plain tin. Remember that this tweezers is translational. It does not have a big dangling. And the last part, after we properly wipe it out. Take a clean lint-free cloth to wipe it. We will take these tweezers after wiping. Clamp it diagonally like this. Damp the 6mm nozzle of the air gun. It also uses a temperature of 320 and a wind speed of 30. First, follow this circle to preheat it. Turn it around twice. Then place it in this triangle with the tweezers. Then put it on. This is called 3-point reballing. Check again after reballing. You can see that there were still white dots below here. Not complete welded. Can be compared with other ones. It's not welded. At this time we can add some flux. Add flux here. And then looking at the changes like this, it has fallen back. At this time it has been processed. By the way, reset the other points as well. Let's wait for a while. Wait for it to get a little bit colder. Then we go to carry the stencil. We are going to carry the stencil this time. This is the effect we report. Let's observe it with a microscope. See if there are any spots that are not soldered. If not, we will reset now. After the net is taken out, use a hot air gun to reset the tin point. The reset is over. This is a safer method. If you encounter this situation when you reball the CPU, you can also learn this technique to operate. First, play it at the point where it is not well welded. Add a certain amount of flux to make it fast welding. Then after we saw the tin board failed, we remove the stencil. In this way, all the solder boards will be soldered well. After removing the stencil, we reset it again. You can see that every point planted by this CPU is the same size. Next, we had to install this CPU. When our next CPU value is over, we will start. Then we go to clean this pad again. Because you have to clean it before you install it. Otherwise, you might put it there. Maybe it comes in a little bit of cotton and ash. It may cause your CPU to install badly, so you have to wash it again. After cleaning it, we smell rosin on it. First, diffuse a thin layer of rosin. Then use an hot air gun to add flux and blow it out first. You can see that the resin on the top now has melted. Add a little bit, no need to add a lot. Just need a little bit of flux to blow it away. Adding too much makes it easy to move. Then blow the flux evenly. Then put the CPU just now. Don't look at the A1 pin for this. Because there are glass crystal underneath, you can directly align the position. Go straight to the right position and leave the gaps on the four sides. Adjust this gap. The hot air gun can assist in blowing, because sometimes the resin becomes hard after it is cold. In this case, resin can actually help you fix the CPU to prevent it from running out of the position. It's almost there now. Take a look around the gaps. After the gaps around are controlled, we use the temperature of 318, wind speed 25 to install. The 6mm nozzle of the air gun blows towards the middle first. Let it pop out the flux. And then rotate it a little bit like this. Wait until it has flux coming out. We can give it a boost. Look at the change in the flux under the chip. You can try it lightly. If there is not a rebound drop, it is not good yet. Because it is inconvenient to operate under the microscope, we can see directly in this way. Just keep spinning. then push it here. It has a rebound action. That's it. Then we wait for it to dissipate. We dissipate it. You can use a fan to speed up the heat dissipation. After cooling down, let's look at the solder joint on this side first. Let's take a look at the solder joints next to us are unevenly welded. You can see that each solder joint under A14 can be seen connected well. Next, let's perform a test on it first. Next, we see the current. Buckle this button. Then we press the power button. There is current. Let's see if it can jump up. There is power and current. Then we take out the screen. Then proceed to install. Install the screen. Attach the battery connector. Then let's see if it power on. You can see that there is a power and current. We wait for it to be on 1A. OK, showing the white Apple logo. At this time, the hello interface has come out. You can touch it. Next, we make a laminating on it. For fitting, we must first flatten these solder joints on the middle layer. I can see it from the lens in the upper right corner. Also add spark flux first. Then use soldering wick and soldering iron. This PCB holder is a big inconvenience. Take it away first. We directly put a paper towel underneath. Then take off the solder joints in the middle layer. It can be seen that the tin on this is relatively difficult to take off compared to the previous model. Because of its high melting point, it is medium temperature tin. When we encounter this situation, we can deal with it like just now. Let's change tin to it. Change this tin to take it off. Replace the tin and remove the tin. Clean after the upper layer is flattened. In addition to this middle layer, its melting point is relatively high. It also needs to be matched with flux. Then we clean the middle layer. Then after we flatten the middle layer, we go to deal with the lower layer. This lower layer is the same as the other lower layers. Also get some of this thin wire first and let it change thin. Just change thin on the soldering iron. Then add some flux all around. Then we take out the soldering rake. Use a soldering wick to let it remove. After cleaning the middle layer thin, we clean the middle layer. Just wash it off with a dust-free cloth. After cleaning up, start planting tin directly. Then we take out the PCB holder. Align the position on the PCB holder. Directly cover. Adjust. Then we this time need to choose thin paste, because the melting point of the iPhone 12 series is close to 183. In fact, if we use 183 for maintenance, it is actually more dangerous, especially for CPU which have been handled. So I recommend using 138 thin paste to reboard the middle layer, because if you use this, even if you encounter reward or something, you can carry out a zero risk repair. If you use 183 thin paste here, you can easily cause an exploding of other chips. Then this method is the same, use 138. Then assert the moisture of the tin. After soaking it dry, do a tin planting on it. Then press the essential and planting directly. You can press down with a little bit of strength, because in this case, you may be able to carry the stencil later. This tin scraper can be pressed down with a little effort. Then you can lift up the stencil in a while. Blow into tin balls. At this time, we have already put all this on. Then take a clean dust-free cloth to wipe. This is the state after wiping. After wiping, we are here to lift the stencil by hand. To lift up the stencil all at once. Then the temperature of the air gun is adjusted to 300 and the wind speed is about 20. Because we can't be careless. Let's take a look at this tin ball first. They are already up there like this. We blow it directly. Blow the tin ball directly. Like this one with yellow dots. It is not a solder joint. Remove it. If it is determined that the wind speed is not blowing well, adjust the temperature directly to 380 degrees. This way the wind speed can also be adjusted up, because at this time most of the solder boards have adhesion. Then blow. Remember to remove this yellow dot. It is not a solder joint. Remove this yellow pass point. Here are 2 yellow pads. Move it out on this side. Remove the yellow one like this. There is also yellow here. Remove it. At this time, we can take a look at these solder joints. Such solder joints can be installed directly. Then we go directly to the next step. You can see that it is ready to be installed now. We now use the heating table to install it back. Then apply some flux. Then this can be directly covered back. Align the position first. The position of the upper board should be right. We turn on the heating table. At this time, the temperature can use the 220 just now, because we had changed the tin to 138. So the temperature we set this time is 180. We are waiting for the temperature to rise slowly. The temperature is about 180 to 160. We can try to see if it can be reset. At this time, we must always observe the motherboard situation. Check if there is solder oil coming out of the middle layer of the motherboard, or smoke. We had to stare at this position of the motherboard. It's about 160. Then we can try. See if this motherboard can push and rebound. There hasn't been a reset action, so it's not completely melted yet. Because the motherboard like normal iPhone X and iPhone XS, it is generally about 160. It has already begun to melt. This is because its motherboard is large, and the heating area is also relatively large, so the temperature may be slightly higher. Be careful not to push too hard, otherwise you'll need to refit. Then we try to push it now. There is a return action. Pay attention. There is a return movement here, so we can push on both sides. Can you see it? So it's down. Then we remember to turn off the heating station as soon as possible. Then there is an iron button, take off. Don't be too fast, pick it up steadily. Can't let it touch the middle. Then we fit. This is done. We can see that the gap here is perfect. It doesn't turn up. You can see that the gap here is perfect. Now you can see that this is fully fitted. This gap has closed. Then we fit it together. And wait for it to dissipate. Use a fan to help it dissipate heat. Speed up heat dissipation. Then we look at this gap. Now it's perfect. Because we are using the iCloud board version. So the single upper layer touch is also on it. Then its display and touch is also on it. So we don't need to test. See you next time.